Okay, so we've looked at orbital notation, we've looked at electron configuration, we've looked at noble gas configuration. Now let's look at valence electrons and the electron dot diagram, or Lewis diagram, or some variation of those words. What we want to show with these are the electrons that are actually going to be involved in the bonding and the reaction process. So not all electrons are involved in a bonding, just the valence electrons, and valence electrons are the outermost electrons. Let's look at an element. Let's look at potassium. All right, potassium is number 19 on the periodic table, so it has 19 protons, 19 electrons for a neutral atom. Instead of doing electron configuration, let's just look at noble gas notation for potassium. So we go to potassium, we go up one row all the way to the right, and we get argon. Argon completes everything up to the end of row 3, so we're going to go straight to row 4, or the fourth energy level. There's one sub-level there for S, and there's one in there, that's potassium. So the highest energy level is that row that the element is on. And the highest energy level tells us the outermost electrons. So if we look at the fourth energy level for potassium, because potassium is on row 4, we have one electron. So we have one valence electron for potassium. All right, let's look at chlorine. Chlorine, the noble gas notation, start at chlorine, go up one row all the way to the right, you would have neon. Now neon finishes row 2, so then we would start at row 3. We have the S block with 2 elements in it, so we are at magnesium. Continue over row 3. The P block, chlorine, is the 5th one in. So the highest energy level is 3. And then we have to count how many valence electrons we have. We have 2 in the S and 5 in the P. So that's a total of 7 valence electrons. So really what you're looking at for valence electrons is the highest energy level and then the number of electrons in the S and P sublevels. Now the periodic table is amazing in the fact that it is arranged according to the highest energy levels. So chlorine was on row 3, so we know 3 is the highest energy level. But it's also arranged by valence electrons. So there's a cheating way or a shortcut to figuring out the number of valence electrons. And that's by looking at the group number. So valence electrons are the outermost electrons, and you can determine them by looking at the last digit of the group number. Okay, so if we were to look at the periodic table and look at chlorine, chlorine being right here is in group 17, and so it has 7 valence electrons. We also did potassium. Potassium is way over here. It's in group 1, so it has 1 valence electron. All right, let's look at copper. No, let's look at nickel. Nickel is number 28 on the periodic table, so it has 28 electrons. If we do the noble gas notation, we would say up one row all the way to the right, argon. That fills out row 3 for us, so we're going to move on to row 4. The S block, there's 2 elements. And then we're in the D block, so it would be 3D, count over to nickel, and it would be 3D8. All right, so what's the highest energy level? 4, right? It's in it's in period 4, row 4. So 4 is the highest energy level. Well, how many electrons are there in the fourth energy level? 2 electrons. So nickel has 2 valence electrons. Remember, the D block is always one less than the row it's in. So the last digit of the group number works if you're in group 1, group 2, or group 13 through 18. But if you're in the D block, it's an exception. So except the D block has 2 electrons. So it's the last digit in the group number except for the D block, which has 2 electrons. So all of these elements in the D block, it doesn't matter which element you're looking at, they have 2 valence electrons, because you're going to go through the S before you go into the D. So it's the last digit in the group number for all of these, but it's 2 for the number in the D block. All right, let's look at drawing the dot diagrams. So what you would do for the dot diagram is show the symbol and then the number of valence electrons. So because we already have these listed, let's do these. So we would say for potassium, K, and then we would draw 1 dot, and that's the dot diagram. For chlorine, we would draw Cl, and then we would do 7 dots. Now we have to follow Hund's rule, which says 1 at a time before you pair up. So we would put 1 on each side, and then we would pair up. And so there's chlorine. Nickel had 2, so we would do 1, 2. It doesn't matter which side you start on, it doesn't matter which side is paired, as long as you have the correct number of pairs and unpaired. So let's go to our periodic table and do a couple more. Let's look at boron, which is number 5 on the periodic table. It has 5 protons, so it's right here. Highest energy level is 2 because it's in row 2 or period 2. It has 3 valence electrons because it's in group 13, and 3 is the last digit. So we would do 1, 2, 3, and there's our 3 valence electrons, and that's the Bohr's model. Okay, let's look at strontium. Strontium's number 38 on the periodic table. It's in row 5 and group 2. So the highest energy level is 5, and it's got 2 electrons there, so it would be ... done. If we look at, argon, okay, argon is in the 3rd row, so 3rd energy level is the highest energy level, and the last digit of the group number is 8, so it would have 8 electrons. So we would do 1 on each side before we pair up. And remember I said that the noble gases, group 18, are full, non-reactive, and so having those 8 electrons makes it non-reactive. It's full. So you cannot have more than 8 valence electrons. 8 is the maximum number of valence electrons. All right, let's look at helium and then we're done. So helium, He, notice it's in the 1st row, right? So the 1st energy level is its highest energy level. Well, how many electrons are allowed in the 1st energy level? Just 2. So helium actually only has 2 valence electrons. So it's another one of those exceptions. So let's go back and add that. So except the D block, all elements in the D block have 2, and helium has 2 valence electrons because helium only has 2 electrons. Make sure you fill out the Google form.